Hey guys, welcome to another video. So today, continue on with the series Calculus Area in the advanced syllabus. Today is the third video in this series. So the intention is to cover some past paper questions that are a bit different, where sometimes they might give you a diagram and we have to either prove something or find an integral, etc. So something a bit different. Guys, if you haven't already done so, there's another video that I put out where I'm requesting for topics that you want me to cover or concepts that you want me to do. If you want to hit up that video in the comment section, just put down whatever topics you want me to cover and I'll try to make it work. I've got a few videos already lined up, but I'll try to weave in some of the requests itself. So also, obviously, if you haven't already subscribed, like the video, please do so. Helps with the search functionality. So let's begin. Now, once again, calculus area. So today, just a few questions where they, sometimes the questions give you an area, and the more key ones that they normally do when they give you the area is they generally try to give you, areas that go positive and negative, right? So for example, if they ever gave you a question where they go, can you please find the integral between A and B, right? The pertinent point there is that this area here is positive, this area here is negative. So for example, if I found this point here, right, the x-intercept here to be C, I might find that the integral from A to C of this function might be, I'm just going to make up a number, positive 10, and then the integral from C to B of the same function might be negative 8, right? And so then what they're going to ask you to do is, can you please find the integral from A to B, right? And then it's a simple case of adding or subtracting in this case to get 2, right? Pretty straightforward, nothing too hard about that, but the concept of positive and negative areas is especially key. Guys, with that concept in mind, let's hit up some of these past papers, right? First one, Sydney Grammar. Now, you can see in this one here, what are we looking at? Let me just zoom in a bit. 4 marks. Wow, there's a lot of marks for Tina question. We'll cut off some words. But in the diagram above, shows the curve cos graph and the x-axis. So the area contained between the cos graph and the x-axis from pi 4 to pi. Don't know why that part of the diagram's cut off, but it is. You know what? It's not cut off. It's just a screen there. That's better. So pi 4 to pi, show that the area. Now, area is always positive. So whenever you're asked to show area, it's always positive. But if the graph has negative elements, then you got to do it in 2 parts, right? You basically do the first part here, take that area, and then when you do the second part, you can either absolute value it to get the positive area, or just put a negative in front of it, because you know that area is going to be negative, right? So this question then is separated into 2 parts. So for the first part, from pi on 4 to pi on 2, we do this function here of 2 cos x dx, pretty easy, right, plus. Now for the blue one, you can do absolute value, but I mean, from a numbers point of view, right, probably easier if I just put a negative in front of it, yeah? And I'll show you, I think I did this last video, where if you put a negative in front of integral, all it does is it flips the limits and just makes life a bit easier. But I think, yeah, let's have a look. So yeah, it does make life easier if you have a negative in there. So integral of 2 cos is obviously 2 positive sign, right? Nothing too hard about that integral wise. On 2 pi on 4. Now, guys, what I'm trying to say here is, if that's a negative, right, you can either minus. Now, maybe I'll do minus for now, right? I'll do minus for now. Yeah, I'll carry down the same route before I flip the limit. Yeah. So what I was saying last week was, if you have a negative, you can actually then reverse the limit and have a positive. Just easier to sub in stuff, right? So let's see. 2 sine pi on 2, just got to know your exact value, sine pi on 4. All right, I'm just going to make that into a plus and then reverse the limits. Oop. When I sub it in, yeah. Actually, let's take out the 2 as well. Sine pi on 2, sine pi, yeah. So the limits are reversed because I've turned it into a plus, right? Let's see what we have here. I've got 2 of these guys, and then you know what? Let's just do them individually. Now, sine, that's 1. Oh, these aren't pretty. That's 1 over √2 or √2 on 2. That's 1 as well. Now, sine pi is 0. So I think my answer is, well, actually, I know what my answer is. I can see it right there. So it would be like 2 times 4. And I think my teacher would probably, you know, if I was doing this question, would be probably happy for me to do this. Pretty straightforward. Yeah, nothing too hard about that. Hopefully that's okay, guys. First question. So just be conscious that if it's area below the curve, it's negative. So if you want to find the area, negative it or absolute value, whatever you want. First question. Let's do another. Helston, 2012. So 2 marks here. What are they trying to say? Looks like it's a combination of 2 graphs, right? Now, in this question, what's the graphs? First one, negative x squared, that's this one. Second one is straight line, that's this one. Now, there's a point of intersection there that's quite crucial. Like they give you the point, brilliant. So that point there has a coordinate of 2, -4, right? That's important for us to go. And so if I was to sort of divide this graph into 2 parts, that guy there has the first integral, and then we'll find the area of the, yep. So this one here now, guys, if they're just trying to find area, don't be silly and try to integrate that. Just use area of a triangle, right? And I'll do it in 2 parts, but what's pertinent is that's negative, that's positive, right? So if I'm finding area, right, just make sure all your areas are positive. So when I do this, right, my blue area is an integral, but see how it's negative? And I know it's negative, so I'll put a negative in front of there, from 0 to 2 of negative x squared dx, right? Yeah, in other words, you're trying to find 0 to 2 of the positive x squared, right? Same thing. Now, plus, for the pink, now what do I have here, right? So I have an area of a triangle, guys. Now, 4x minus 12, the y-intercept there, what's that? When y goes 0, that's 3, isn't it? Yeah, and it goes all the way to, what's the corner of C? Does it say 4? It's all right. It doesn't look symmetrical. Let me just check. Yeah, I think that's right. It's just, okay, not to scale, very not to scale. Okay, cool. So is it just me? Or, okay, let's see. For the pink, feels like this area here, I mean, what's the height there? Height is 2. Base is 1. That's a half times, is that right? Times 2 times 1. Is that right? Oh, no. Coordinate C, it tells you that this is super steep. Jeez, okay. So height is 4, right? 4, okay, cool. Got it. Cool. The shape of this guy is throwing me off. So let's see, you know, let's draw this. So I got a triangle that looks like that. This is 4 and this is 1. It's just not to scale, guys, just not to scale. Plus, triangle that looks like that, and I think this one here also has coordinates to say. Probably not, but if I sub 4 in 16 minus 12, yeah, that's 4, 4. Yeah, once again, it's 4 and 1. Oh, man, that scale, nasty. So, guys, integral negatives cancel out. That's x squared, so x cubed on 3, 2, 0 plus half times base times height, or height times base. And there's 2 of them, so exactly identical. Guys, 8 on 3 plus, what's that? 8, 4, is it? 4, let's put them together, 20 on 3. units squared. Yeah, nothing too wow about that. Yeah, is that cool, guys? I'm just gonna mute myself. Just gonna blow my nose quick. Back. All right. So hopefully that was okay. Nothing too hard about that, but just be conscious that sometimes if it's a triangle, why integrate? Let's just use measurement, right? Area of a triangle, piece of cake. Next, I like this question, right? This question here is, something that a lot of people don't appreciate. Now, can you see what the question's trying to do? It gives you like a weird shape with positive, negative areas. And then it says, can you please find the integral from -1, right? From -1 to k. So from here to here, right? And that equals 0. Find the value of k. In other words, every area that's positive, right? This guy, right? Exactly offsets the area that's negative, right? So measurement-wise, the areas are exactly offset, right? So what I'm going to do, the way I'm going to do this question is, I think all the shapes are either rectangles or triangles, right? So we can actually just use our measurement skills. There's nothing really wow about this, right? So for example, this guy here, that's base, that's height, that's an area of 2, right? Now, for example, this guy here, now I can, God, this feels like year 8, right? Where this is base of 2, height of 2, area of 4, that's height of 2, base of 2, that's area of 2, right? So right now, that's my area so far. And then the last triangle piece here for the positives, I've got a height of 4, base of that 1. Base of 1, height of 4, so area of 2. So I've got 4 areas. Man, these diagrams that are not to scale are really making a real, I think that's where the majority of the marks are. Trying to figure out diagrams. So the positive, so the integral from -1 to 3 of the function right now, right, which is basically representative of the positive area. 2 plus 2 plus 4 plus 2 is 10. Yeah, that's what it looks like. Now, for the pink, it's a triangle, right, that has, oh, geez, okay, let's have a look. What's this? It's got a base of k minus 3. Yeah, does it, any information here? No. Right. And then it's got a height. Ooh, this is why it's hard. I don't have a height, but I do have something. Now, let me see if I can use it. I do have a straight line, don't I? Yeah. So if I can find the equation of the straight line, sub in the value of k, then I get a height. And maybe it's a quadratic of some sort. Cool. So for this area of straight line, what do I know? Yeah, what do I know now? I know the rise over here and run here. So the rise is -4. The run across is 1. It's got a gradient of rise over run is -4, right? Great. So then y minus y1. So I'm going to use the x-intercept, right? Y minus y1 minus 4, x minus 3. Looks like my equation straight line is minus 4x plus 12. Great. Right? Got the equation of a straight line, which then gives me to find this coordinate here, right? When x equals a k, sub k in, what's that? Minus 4k plus 12. Oops. Right? That's a coordinate. So this height here is minus 4k plus 12. Now, then the area of this guy, right? The area of the negative part. So the integral from 3 to k, yeah, of the function dx will be the area of a triangle at the half times base, k minus 3, yeah, times height. Now, let me just make sure my working is fine. Looks okay. Looks okay. Is that right? Yeah, it looks okay. So then a half. Oh, I think this is actually quite nice because if I factorize the -4 out from here, right, I get k minus 3, and what's that? K minus 3, isn't it? Yeah, perfect. So that's like -2 k minus 3 squared. Yep. Now, I know that the area negative plus the area positive is exactly 0. So the area should be exactly the same. So I just need to absolute value this guy, right? So therefore, my conclusion is, if I can set the absolute value of this guy, right, equaling this guy, I should, so this guy equaling to the absolute value of this guy should give me 0, right? They exactly cancel out. So therefore, 10 equals to the absolute value of that guy, which makes it positive. That. Now, considering k is a positive number, when I square root it later, it should be just one answer. So that's 5 equals a k minus 3 all squared. So then k equals to plus minus root 5 plus 3. Is that right? No, not plus minus. I just said k is positive only, right? Yeah, because it's on the positive side of the question. You get that. How's that? Right? Nice question. Nice. I can see why it's 4 marks, because that straight line, finding an equation straight line, finding a coordinate, that was not clear from the question itself, right? So it's a nice little question that's hidden. Sorry, nice little working out piece that was hidden in the question. In its simplest form, in the diagram before I drew all over it, actually looked quite simple. So I like this question. It was much harder than what it looked. Guys, I've got 2 more questions. So let's see how they are. But the 2 questions have a similar theme, where questions here, the first question from Hornsby Girls basically says, yeah, here are 2 graphs. I'm going to give you the area, and then they want you to find a parameter, right? So let's have a look. Okay, for some reason, every time I zoom in, parts of the graph disappears. Okay, so I've got a parabola and a straight line where it's y equals mx passes through origin. Okay, cool. The area enclosed, maybe I use green because red and blue. So the area enclosed, yeah, is given to be that. That's the area, yeah. Find them. Okay. So this red graph is y equals mx, and the blue one is y equals x squared. Okay, I'm just gonna label that. Now, obviously, I mean, biggest thing that's missing right now, I know it's from 0, right? And I know that guy's missing, so let's call that A, right? And it's telling me, guys, that the integral from 0 to A of top minus bottom, so of mx minus x squared, yeah, it's telling me that is 32 on 3, right? Don't get fancy with our colors, a bit distracting. Yeah, that's what it's telling me. Now, what I don't have right now is a sense of, there's 2 parameters here, m and x, right? What I can do is, I normally, to find A, I need to solve simultaneously. Let's do that, right? Let's see where that takes us. So to solve these guys simultaneously, right, I get x squared equals mx. Guys, move the mx over. X squared minus mx. Factorize the x out. X minus m, 0. X equals to 0 and m, right? So can't be 0. So actually, in this case, A is m, right? So basically, if I replace that guy with an m, yeah, I should be able, let me just check, that's right, yep, looks fine. So that's my answer. So now that I've removed, I had 2 parameters, A and M, got rid of A, now it's just M. All I got to do now, integrate, set it, and it hopefully, it's something that's easily integratable. Let me just check. Yep. So not easily integratable, but then easily solved, right? Let's see. Oh boy, I hope it is. I'm a bit weary. Oh no. Am I weary? No, should be all right. My first impression was I'm a bit scared because when I integrate this, I'm going to get x cubed and x squared, and it looks like I'm solving for a cubic. But I think when I sub m in, it just becomes quite straightforward. So let's persevere. Okay, let's go. Let's go. Yeah, I don't know how you guys feel about doing these questions. I always try to look ahead. So once I integrate, I know it's a cubic, and then I'm going to sub things. Normally if it's numbers and stuff, and I'm trying to solve for a cubic, not great. But in this case, I think it'll work. Let's see. Yeah, let's see. So I just try to give you a peek behind the curtains of my thinking. See, normally not great at this point, but you'll see that when I sub in the m, right? Because when I have a squared and a cube, it's very hard to solve. But when I sub in the m, they both become cubes, right? So 0 is gone. So let's shortcut that. So if I sub in m into here, I get m cubed on 2. Sub in m here, yeah, m cubed on 3. That's good. Yeah, that's perfect. On 3. So then what's that? M6. Is that 64? Ah, great, perfect. Now, is m positive? Definitely positive. So therefore, it's always, yeah, sorry. Cube root's always positive anyway. Okay. M is 8. Let me just quickly check. That's all right. Cube root of 64 is not 8, it's 4. There you go. Perfect. Wicked. All right. So that question there, normally they go the other way and they go, they give you y equals to 3x or 4x, and then they, say find the area between two curves, and then you basically find point of intersection and do it. But this time around, gave you the area, had to find the point of intersection, and then found the parameter of m. Quite good. It feels much harder when you go backwards, right? Because a lot of people get caught unawares. In this case, there's a and m, right? And makes it a bit harder. But this is the process, right? You just persevere like you normally would. Find the point of intersection first, and then sub in the parameters, right? And the only bit that sort of, in my mind, because I've seen these before, caught me a bit off guard, maybe because I was overthinking it, was I was trying to think maybe I couldn't solve a cube and a squared in the same equation. But in this case, once I subbed them in, right, they both became cubed and I could sub it. I can solve it. Guys, I've got one more question from the HSC, right? 2020, same concept, right? Where it looks like it's area between two curves. Once again, you can see there, guys, there's a parameter missing, right? There's a parameter missing, show that x coordinate. So firstly, they tell you, can you please find the point of intersection there and show that that is 4 on a plus 1, and then find a if they give you the area. Okay, very similar, right? So very similar to what we've been doing. So a x squared is the bottom curve, right? Always identify top and bottom when you're doing area between two curves. That's the top one. Yeah. Okay, so now let me just see. I think it's a straight point of intersection, right? So part A, show the x coordinate. So if I said y equals to ax squared, I just realized it was 6 marks. Jesus. And that's equation number 1. And y equals to 4x. Y is x squared. That's equation number 2. Yeah. Sub 1 into 2 to solve simultaneously. Let's see, ax squared, 4x, minus x squared. What am I doing? Making a the subject. Okay, cool. Let's move everything over. So I get what? A plus 1. X squared minus 4. X equals 0. Factorize x out. Plus 4. Equals 0. Therefore, x equals 0, or is that 4 on a plus 1, right? Since a is greater than 0, and you'll see it there, therefore, x coordinate of a is 4 on a plus 1, since a is bigger than 0. Yeah, done. Also, since yeah, I was going to say since A is maybe A greater than 0 isn't the reason. It's basically just non-zero, right? Don't even need a reason for that. Right, and not finding the one at the origin. Yeah. Now, next part is similar to what we did before, right? Where, so I'm just going to move this up, give me some space. 4 marks. Wow. Okay, cool. So same deal as before, guys. Basically for part B, right, find the area of the shaded area is that feels like all I got to do is go from 0 to the point of intersection. In this case, I think the numbers will be just ugly because A is on the bottom and stuff like that, but it's top. So 4x minus x squared minus, oh, there's an A in there as well. Fancy, right? Ax squared dx, right? And I'm going to integrate that, but I know that this guy equals to 16 on 3, right? That's my problem, right? And I think it's just, okay, I'm preparing myself for like an algebra nightmare. So let's see. Okay, I'm going to integrate this out, but that becomes 4x squared, so that's 2x squared. Should I do this separately? Let's factorize a plus 1, right? Minus a plus 1, and it'll be x cubed on 3. So x cubed on 3. Yep, 4 a plus 1 and 0. I think it's better if I factorize it, because when I sub it in, I'm hoping that the a plus 1s cancel out somewhat. Okay, let's see. Okay, 0, when I sub it in, it'll go away, so I won't sub that in. I'll sub in this guy first, so it'll be 2 times 4 on a plus 1 squared minus a plus 1 on 3 multiplied by 4 cubed 16 on 3. Let's see, that guy, and I guess that guy goes to squared, right? Just yeah. The working out isn't the best there, but you know what I mean. 2 times 16, that's like what, 32 on a plus 1 squared minus, what do I have here? 64 on 3. 64 on 3, a plus 1 squared, 16 on 3. Now feels like, too low. Well, feels like I've run out of space, but okay, I don't need to work. I'm just copying a new slide. I want to maintain that, get rid of that. Do this, zoom. Okay. Just can times everything by timesing by 3, and then everything by a plus 1 squared. Okay, cool. 32 times 3. Actually, if I times it by 3 and minus 1, it'd be double 6. I think if you times everything by 3, that would be 96 minus 64. Times it by 3 is gone, and then times it equals to 16 a plus 1 squared. All right, so that's 32, is it? I think my algebra is right. Guys, if I'm wrong, let me know. That's 2 a plus 1 all squared. This is good. This is turning out quite nice. Therefore, a in this case is plus minus root 2 minus 1. Now, have a quick look. I think a is positive, isn't it? Yep, a is positive. I remember in the question. Therefore, root 2 minus 1 only. Guys, not too bad. Oh, well, I was expecting worse. That's 4 marks. That's how you do it. So I guess whenever you're given a question where, in this case, another parameter is missing, persevere with the concept that it's area from the one above minus the one below. And when you sub in your limits, hopefully then you'd be able to solve whatever equation. In this case, it's quadratic, but it's already factorized, quite straightforward. Guys, hope you liked the video. Give us a like, subscribe to the channel, and tell your friends. And if you haven't already done so, go to the video where I'm asking for requests, put down the topics that you need, and I'll try to address it in the future. Thank you.